Good evening, everybody. Welcome back. Welcome back to another session for domain analytics. So we are working on the domain analytics from past 3 days. So today is the day 4. So we will be discussing on the oceanography analytics. In that, we will cover today unsupervised learning, nothing but we call it as K-means clustering. So let's take a recap. So we have discussed about introduction, business understanding, data understanding, and we have also discussed about the data pre-processing and exploring data analysis, nothing but EDA. So we have discussed all the categories what it undercome. In that we have also discussed some functions and what are the libraries used in the EDA processing. So before starting the unsupervised learning K-means clustering oceanography analytics, so I will quickly share something that is nothing but this is our 360DigiTMG website. We have plenty of courses. We have data science, deep learning, MLOps, data engineering, cloud, domain analytics. So in domain analytics, we also cover all the HR analytics course, market analytics, financial analytics, all these things. So if you are interested, you can visit our website. So in our YouTube channel, we have a lot of content like analytics, domain parts. So you can learn through there. So we'll start with unsupervised learning. So what is unsupervised learning? So unsupervised learning is also called as unsupervised machine learning. So which uses machine learning algorithms to analyze and to cluster the data, or to analyze and cluster unlabeled data sets. So these algorithms discover hidden patterns, or I can say hidden grouping, without the need for human interventions. So here unsupervised learning also called as unsupervised machine learning also. So its ability to discover similarities and differences in informations. So it makes it ideal solutions for exploration, exploratory, data analysis, and cross-selling strategies. So the customer segmentation and image recognitions. So what are the common unsupervised learning approaches? So unsupervised learning models are utilized for three main tasks. So they are clustering associations and dimensionality reductions. So below we'll define each learning method and highlights common algorithm and approaches to conduct them effectively. We will know what we will be discussing all those things. So what we'll be discussing today? So we will discussing on the unsupervised learning. Then we will move on to the clustering. What is clustering? How it is used? What is the use of clustering? Then we'll move on to the k-means clustering and the advantages of the clustering and unsupervised learning also. What are the limitations? And some key concepts, and we will discuss at last of use cases on the oceanography analytics. So first we'll start with unsupervised learning. So unsupervised learning is when it can provide a set of unlabeled data which is required to analyze and find the patterns inside. So the examples are dimension reductions and clustering also. What is clustering in this unsupervised learning? So clustering is a data mining technique which groups unlabeled data based on the similarities or differences. So clustering algorithms are used to process raw unclassified data object so into groups and represent by structures or patterns in the information. So clustering algorithm can be categorized into few types. So they are mainly, I will explain one by one. So they are exclusive, overlapping, and hierarchical. And finally, probabilistic. So these are some types of clustering. So exclusive and overlapping clustering. So exclusive clustering is a form of group so that stipulates a data point can only in one cluster. So that can be referred to as a hard clustering. So the k-means clustering algorithm is an example of exclusive clustering. So we'll show in the mind map. So, yes. So in the supervised learning, here we have clustering, dimension reductions, associations rules, recommendation system, network analysis, text mining. So today we will discuss on the clustering part. So here we are in the hierarchical clustering, partition based on clustering, density based clustering, grid based clustering, and probabilistic evolution. And finally, we have reduced the number of rows. So in hierarchical, yeah, in k-means clustering is a common example for an exclusive clustering where data points are assigned into k groups where k represent the number of clusters based on the distance from each group of a centroid. So the data points and the closest to given centroid will be clustered under the same category. So a large k value will be indicated of small grouping with more gradually, whereas a smaller k value will have large grouping and less granularity. So the k-means clustering is commonly used in market segmentation and documentation clustering. So in document, we have image segmentation and image compressions also. So overlapping cluster differs from executive clustering in that it allows data points to belong in multiple clusters with separate degree of members, such as soft or fuzzy k-means clustering is an example of overlapping clustering. In hierarchical clustering, so in hierarchical clustering is also known as hierarchical clustering analysis, which is HCA. So HCA is an unsupervised clustering algorithm that can be categorized into two ways. They can be agglomerate or divisive. So agglomerate clustering is considered as a bottom-up approach. So its data points are isolated as separated grouping initially. And then they are merged together initially on the bias of similarities until one clustering has been achieved. So four different methods are commonly used to measure similarities. So we will discuss all the four measurements. The four measurements are Watts linkage, and the second one is average linkage. Then we have maximum linkage. Then last we have single or we can call as single or minimum leakage. So we will discuss all the 4 points. Now you can see the blasted things. Yes, so in word leakage, so this method stages that so the distance between two clusters is defined by the increases in the sum of the square after the clustering is after the clustering are merged. So in the average linkage, so this method is defined by the mean distance between 2 points in each cluster. So in the complex linkage thing, but or we will call this maximum linkage. Then we have single or minimum linkage. So in the complete linkage, the method is defined by maximum distance between only 2 points in each cluster. So in the single leakage or minimum leakage, so this method is defined by the minimum distance between 2 points in each cluster. So that is in the maximum and is in the minimum. So this was about the 4 different methods for measuring of similarities. So Adelian distance is the most common metric used to calculate the distance. However, other metrics such as Mamertine distance are also cited in clustering lectures. So the device clustering can be defined as the opposite of algometric clustering. So instead, it takes a top-down approach in this case. So a single data cluster is divided based on the difference between data points. Device clustering is not commonly used, but is still worth nothing in the content of hierarchical clustering. So then we have probability clustering. So in the probabilistic clustering, PS, we can say PS. So the PS model is an unsupervised technique, so that help to solve the density estimation or soft clustering problems. So in the probabilistic clustering, data points are clustered based on the likelihood. So they can belongs to a particular distribution, and the Gaussian mixture model GMM is one of the most commonly used PS methods. So in the Gaussian mixture model, so these are classified as a mixture models, which means that they are made up of an unspecified number of probability distributions. So the GMMS are primarily leveraged to determine which Gaussian or normal probability distributions is given data points belongs to. So if the mean or the variance are known, then we can determine which distribution is given data points belongs to. However, in the GMMS, these variables are not known, so we can assume that a latent or hidden variable exists to clustering data points approximately. So while it is not required to use the expectations maximizations EM, so the algorithms it is commonly used to estimate the assignments probabilities for a given data points to a particular data clusters. So it's about the Gaussian mixture model. Then we have association rules. In the association rules, so rule based on methods for finding the relationship between variables in the given data set. So these methods are frequently used for market-based analysis. So it's allowing companies to better understanding the relationship between different products, understanding and consumption habits of customer enable business to develop better cross-selling strategies and for recommendation engines. For example of this can be seen in the Amazon customer who bought this item also bought or Spotify's Discover Weekly playlist. So while there are a few different algorithms used to generate associations rules, such as a priori, LCLAT, and FB growth. So the a priori is an algorithm is most widely used. So in the a priori algorithm has been popularized through the market basket analysis and leading to different recommendation engine for music platforms and online retailers. So they are used with the transactions data sets to identify frequently item sets or collections of the items, to identify the livelihood of consuming a product given the consumptions of the another product. For example, if I play Black Sabbath radio on Spotify, so starting their songs or trade, one of the other songs in the channel will likely to be lead Zeppelin songs such as Over the Hills and Far Away. So this is based on my pure listening habits as well as one of the other. So this algorithm used as a hash as a tree to count item sets and navigating through the data sets in the breadth first manner. So this was our algorithm. Then we have dimensional predictions. So while more data generally yield more accurate results, so it can also impact the performance of machine learning algorithm. Example for overfitting, and it can also make it difficult to visualize data sets. So the dimensionality reduction is a technique used when the number of the features or dimensions in the given data set is too high. So it reduces the number of data inputs to size while also preserving the integration of the data sets as much as possible. So it is commonly used in the pre-processing data stages. And there are few different dimensionalities reductions methods. So that can be used, such as principal component analysis, nothing but PCA. So we'll discussing on the PCA. So let us check what we have coded in the mind map. Yeah, we have completed hierarchical. So we'll discuss all these things. So we have done with dimension, associations. We are done with this algorithm. One minute. Yeah. So we will discuss on the PCA, principal component analysis. So PCA, nothing but principal component analysis, is a type of a dimensionality reduction algorithm. So which is used to reduce the redundance and to compress the data sets through the features extractions. So this method used as a linear transformations to create a new data representations and yielding a set of the principal components. So the first component is the direction in which the variance of the data sets, while the second principal component also find the maximum variance in the data. So it's completely uncolorized to the first principle. So to the first principal component, yielding is a direction that perpendicularly or orthogonally to the first component. This process repeats based on the number of dimensions. Where a next principal component is the direction orthogonal to the components with the most variance, we can say. In this, we also have a SVD called as singular value decompositions. So yeah, SVM, singular value decomposition SVD, sorry, SVD. So it's another dimensional reduction approaches which factorize as a matrix A into three lower rank matrices. So the SVD is denoted by the formula A USVD, where U and V are orthogonal matrices. So here where you and we are the orthogonal matrices, and S is a diagonal matrix, and S values are considered as a single value of a matrix A. Similar to the PCA, it's commonly used to reduce noise and compress the data such as image files. So this was about the image clustering. So here you can see a diagram of unsupervised learning. First, we have the training of the data, then historical data. Then we put the data into machine learning. Then we have some patterns, rules and patterns to the machine learning. Then we'll do predictions for the new data. And we use machine learning algorithms for the predicted outcomes. Yeah. Here we have unsupervised learning, as I mentioned before. So unsupervised learning is a machine learning technique in which models are not supervised using the training data sets. So instead of models themselves find the hidden patterns and insert from the given data. So it can be compressed to learning which take place in the human brain and while learning new things. The goal of unsupervised learning is to find the underlying structure of the dataset. So group that data according to similarities and represent the datasets in the compressed format. So the resultant clusters will have low variances. So this is the clustering diagram, which is unlabeled data and labeled data. Here we have k-means clustering. So it is an unsupervised learning method that aims to group similar data points in the clusters. So it is a centroid based algorithm where each cluster is associated with the centroid. So the main aim is to algorithm is to minimize the sum of the distance between the data points and their corresponding clusters. So here are the steps of the involved for the k-means clustering there. Step 1, we have initialized the centroid k. For the step 2, for the each sample in the sets of the samples assigned. So the sample is to closest cluster k. So based on the Edlund's distance, so it sets the samples assigned to the closer cluster k. For step 3, each cluster in the set is a cluster. So it recalculates the cluster centroid based on the mean of the sampling in the cluster. So step 4, then repeat the step 2 and 3 until a stopping conditions is fulfilled. So in step 5, determine the variance for each cluster and sum is. Then repeat step 1 to 5 with different initializations of the cluster centered positions. So let us take look into the code. Here, so here for clustering, we have taken a code. We have taken and some of the university data sets. So here we have imported pandas, NumPy, and matplot. So these are the libraries which are used in the Python. Then I have from sklearn, I have imported the k-means cluster. Then I have given the values x and y where random uniform as a 0, 1, 0, 1, 50. Then I have given a column as x and y. Then the data frame will be like this. Top 10 colleges, sorry, universities. So here is the data sets of x and y. Total 50. So we are counting from 0 as a 1. So it will be 1, 2, 3, 4, 5. So it will be not 40, it will be 50. So here you can see the plots. Here we have scatter plot. Then you can see the clusters here and here. Then we can find what are the how many numbers of the clusters we have here. We have used here plot. Yeah, so for getting the label data of cluster assigned to each row, we have taken MB as a PD series model label for converting the numpys arrays into the pandas series object, and for creating a new column and assigning it in the new columns. So here some are the advantages of the k-means clustering. So the k-means clustering algorithm is used for the groups and unlabeled data sets instance into the clusters based on the similar attributes. So it can scale well within the large data set also. Then we have k-means is the most commonly used clustering method, for largely due to it being which is inexpensive. So it is an appropriate method when you know the number of clusters to be drawn from the data sets, and it is speed as well. So we will go through our we have done with hierarchical clustering. Yes, we have done with the density based clustering. So it's basically work for the non-spherical shapes, and which has two parameters: maximum radius of the neighbors and minimum radius number of points. Give me a minute. So we have done with this. We have done with this hierarchical clustering also. Evaluation techniques. Okay, so we'll discuss on the evaluation techniques. So evaluation techniques are nothing but Leotic coefficients. It is an initial score which is used as RI as a RAND index and Dunn index also. We have done with association rules, recommendation systems. So in the network analytics, so network analytics also called as the graph data. So here the network can be represented as an adjusted matrix. So network can be directed or indirect, undirected. So one can be characterized the networks using the node properties or the link properties or network properties. So for the functions of the Python, we use here all these things you can go through: graph, add graph, pandas, edge list. Here we have drawn networks. All these are functions of the Python for the network analytics. So here we have some limitations. For the unsupervised learning. First one is the number of clusters must be chosen upfront. Then we have outliers can have a strong influence on the results. Then we have initial centroid positions have to be strong influence on the results. Then we have it does not cluster well with the clustering of varying size of the densities. So these are the limitations. And here we have some key points. So for stability run, The K means clustering multiple times called as a iterations with different random chosen K value. So this will address the multiple local minima values. Then we have a data point must keep the oscillating between two clusters. So for the each of the run and the specifying maximum number of the iterations. Then we have convergence criteria is to stop when a cluster center moves less than a certain percentage of a smallest distance between any of the centroid. Then we can compare between clusters variations to within the cluster of variations, where we have typical objective functions used in the sum of the square errors for the K-means clustering. So we will discuss on the use cases. So for the use cases, section The technology for the high resolution chemical measurements in the oceans it's described it is described as the potential or already have been proven the ability to measure chemical parameters. So in the C2 with the high temporal or yeah, to measure the chemical parameters in the C2 with high temporal or the spatial resolutions. So the technologies described below provided example that hopefully will serve the stimulated ideas for the new chemical sensors. So in the data integrations, the common use in the C2 chemical sensors is expected to lead to a marked increase in the volume of the data for chemical parameters. Accordingly, a new method must be developed for the process of this data. The physical oceanography has long been dealing with higher data rates from CTDs and ADCPs and for robust methods for the data handling and storage, as well as established for the profiling measurements. So the operations of ocean observations will be they granted of number of sensors. So in the development, highly interdisciplinarity. So it involves the oceanography science that has the sensors are applied to physical and chemistry for the development of the detector and transducer electronics for the signal processing and control the mechanical engineer for the packaging the instruments and for the information technology for the processing the data streams for the instruments. Only when all of these parts works together can sensor be successfully developed in within a period that scientist. For many, for many analytics of internet's interests for the chemical oceanography, no stand exists that could be used for the reference for sensor calib for a referral of sensor calibrations. So using community-wide accept standards would be also be easy to the intercomparisons of different sensors for the same analytic. For the area of the coastal research tools and technologies, so the aliens of the coastal technologies carried out the workspace, work, shops, and the evolutions and comparisons of sensors and technologies. So in the platform used to carry all the kinds of oceans and atmosphere sensors. So the mode bias first appeared during the World War II. So the submerged buoyant system was used for the US in the early 1950s for the subsurface and the deep sea environmental monitoring. Drifting buoys are mobile observation platforms developed according to the needs for specific ocean experiments and environmental monitoring plans. So in the late 1970s, as the computer and satellites communication technologies began to be applied, so the technology development fast. So the development of ocean buoys in China began in the mid of 1960s. So the first put in 1990s. So China is one of the most countries that makes a major contribution on ocean monitoring using buoys. So here in ocean remote sensing, So ocean remote sensing is used to use of sensors to conduct remote and non-contact observations of the oceans to be obtained and image or the data related to the ocean landscape of its constituent element. So the development of the ocean remote sensing can be roughly divided into an initial period. So in the model and reanalysis data for the use cases, by combining the basic physical process of the oceans and a high performance computer as a mathematical model can be established. So as they simulated the ocean states, including the temperature, ocean currents, waves, tides, and other elements, and describe the specific conditions of the oceans in the parameterized and quantitative way. With the rapid improvement of the computer computing power, and numerical simultaneous of the oceans have developed greatly in recent years and gradually become an important source of the big oceans data, such as POM, Precision Ocean Model. So variety of new technology and the equipments have been gradually forming in the three-dimensional and multidisciplinarily and integrated ocean data. And detection network that has high spatial and temporal coverage. On the whole, acquisitions of the oceans data has moved from traditional means to new technologies. On the whole, the acquisitions of the ocean data has moved from the traditional means to the new technologies, and from the single factor to multiple ones, and from the single survey to operational normalized survey, thereby establishing the concepts of big data in the terms of the total amount of the ocean science data in the constant data acquired by the traditional means, and the deep sea data are relatively scarce and so can be considered small data in the content of the better understanding of the ocean. So the small data cannot meet the needs of the effective sampling as a space-time scale. So here in the conclusions for the use cases. So the development of the modern ocean science can be divided as the data-driven stages has developed. So the opportunities and the challenges as arisen, great opportunity exists in the relations to changing the paradigm of how people understand the oceans. However, it will take a long time to realize and compressive big data in the oceans. So on the sorry, on the applications levels, so the ocean data are useful for the climate predictions, environmental detections, water quality survey, scientific research, etc. In the fact, the ocean values of the oceans data can be expanded when they are combined with the ocean economy and the data owner federate with the users. So eventually, ocean science education in the industries will be transferred into an evidence based in the database science. So a focus on the theory in the field of ocean science and the technology innovations is also required. So we have done with unsupervised learning, clustering, k-means, advantages, limitations, key points, and use cases.